Today I'm going to show you how to build an AI-driven meme search engine. And the reason why I put this together is I like to keep all my memes and images that I send to my friends when I'm chatting in a directory separate from family photos and stuff like that. And whenever I needed to find an image or like query my image database, which is just a directory on my machine, I had to do what I'm showing you here, which is scroll through a bunch of file names and maybe look at the thumbnails to try to recover the exact meme that I'm looking for. Now, if you only have like 5 or 6 images in a directory, that's not such a big deal. The querying is pretty trivial. But as soon as you get dozens of these, or maybe hundreds of them, and some of the file IDs might be just random, given to you by screen cap software, then it becomes very non-trivial to query for an image in a directory like this. So I thought I would build my own little AI-driven meme search engine and share it with you. Today, I'll show you that app, show you how it works. It's very simple to use. I'll show you where you can find it, how you can install it and set it up. Then I'll talk to you a little bit about how it works on the back end. It's a pipeline that consists of more or less 2 AI models, a vector database, and some custom code to sort of sew it all together. So I'll describe that at a high level. And last, I'll briefly introduce you to a Colab notebook that goes into each of those components more deeply and illustrates and pulls apart the code for you, just in case you want to go into further details yourself. So let's get started by assuming like this is my set of memes here. I've collected 9 safe for work memes. So these are going to be our test images. When I'm showing you the app in just a moment and how you can query and recover images, these are going to be the images I'm going to be trying to recover for the sake of illustration. Here is the app itself. It's very simple. It has a single search bar. So say, for example, I wanted to find this image via natural text query. On this image, I could look for the keywords that are printed on the image. I could look for both pills, for example. Okay, can recover the image that way. If you look underneath the image, you'll see the text-based description that was extracted from it. In this case, if I zoom in a little bit, the image shows a close-up of a bald man wearing sunglasses and a black leather jacket with a serious expression on his face. Overlaying the image is a question in bold white text that reads, "Did you just take both pills?" And then you'll also see a query distance here. This is a distance measurement between the input query here, both pills, and a component of this text. The app itself will return the top handful of results from that test batch that I showed you that most closely align with the input query. So in this case, the next closest image to the input query, both pills, is this image here. And you can see here that the query distance is way larger for this second image. So the second one is much less similar to the input query than the first image is. The query distance of the first image was 0.1. The query distance of the second image is 1.5. And then there's a third image that's even further away in distance because the query matches it even less. And then a fourth image shown, etc. Okay, so you can search via the exact text, and it's really the exact text that has been extracted from the image, which is shown below each image in this app. Or you can look for your image semantically. So like say I wanted to recover this particular image, but I don't exactly remember what's in it or what the text on the image says. If I don't remember, say, what the text on the image says, I can look for something similar like 2 capsules. I'm looking for, and I can recover the exact same image as my closest match because 2 capsules is another way of saying both pills. Here's that test batch again. Let me just show you one more example of how you can query out the exact meme that you're looking for. Say I was looking for a man in a black jacket. That's the meme I'm looking for. Well, I can see just visually here, I have 2 memes that have a man in a black jacket. This one actually has a man in a black leather jacket. But if I query for black jacket man, say, okay, I'm going to get this image or this meme as my top result with the lowest query distance, because if you look at the text description that's been extracted from this image, it says a man in a black jacket, blah, 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 blah. So my query matches exactly with that image. And then next in line, I get back the next closest image, which is a man in a black leather jacket. So you can see with this simple app, right, you can take a directory on your desktop that's filled with memes and images, index them by extracting the text-based descriptions of those images to make the querying of your images a heck of a lot easier. Because as soon as I find an image, like say I wanted this one, I can just click on it and drag and drop it into a messenger. Okay, next let me briefly show you where you can find this app if you want to pull it and install it yourself. It's located at this GitHub repository. I'll leave a link in the description to this. There's more than just installation instructions in the README. There are links to the tools used in the backend that we'll talk about in just a moment. That includes the AI models and the vector database used, etc. But if you scroll down, you'll see a section titled Installation Instructions here. There are 2 steps to run the app. First, pip install the set of requirements that you'll find in the repository. And 2, run this command at your terminal. This starts up the app. There are also instructions in the README just in case you want to index your own images and memes. Now let's talk about how the pipeline works. That is the thing that takes in an image, extracts a text-based description of the image, and then makes that searchable. So the pipeline here consists of 4 parts. The first part is an AI model that extracts text-based descriptions of the input image. There are multiple options that you could use for a pipeline like this, or as I've used in this case, you can use a vision language model as well. The second step is text chunking. So you take that text-based description and cut it into a bunch of chunks or snippets that basically increase the query surface of that image so that people can type in 2, 3, 4 word queries and more easily recover that exact image. Next, in order to make those chunks actually queryable, you have to transform them into numerical vectors and then dump those into a database that's equipped with something like a k-nearest neighbor search. Here are the specific models, etc. that I used for this app's pipeline. For the image to text component, I use the tiny vision language model Moondream. There's a link to this in the README. It's a very powerful tiny vision language model that you can run locally on your own machine. For the text chunking, that is cutting the text into pieces, and I'll show you a visual of this in a second, I use some custom code, no big deal there. For the text embedding portion, that is when you take the snippets or chunks of text from the previous step and turn them into vectors. I use the very popular model from Hugging Face. And for the vector database, I use the open source vector database Face. Now I'll describe a little bit more about how each of these steps works. Step 1, that image to text conversion or extracting the text-based description of an image, works at least at a high level exactly how you would imagine it. You take an input image, shove it into the model, in this case a vision language model, and the output of that model is a text-based description of that image. And in particular for memes, things that have just a little bit of text on them especially, this kind of vision language model also does a pretty great job of extracting text printed on the image as well. Next, you chunk that text-based description, and you're going to do this for each image. So in this case, that means you take the text-based description that you got from the text-to-image model, and then you cut it into a bunch of different snippets. So you take a description that might look like this, a bald man wearing sunglasses and a black leather jacket, blah, 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 and you cut it into pieces like this. And those pieces can overlap. And why do you do that? To expand the query surface for possible recovery of that image, because you or whoever uses this meme search engine app might want to recover that image by using a phrase that sounds something like any of these snippets, like a bald man wearing sunglasses, a black leather jacket, a serious expression, or something about taking both pills. Because there are multiple possible ways that someone might query for that image, you want to make sure you capture as much of that as possible by chunking that text-based description. Next, you take each of those text chunks and you transform them into vectors. That's the part of the process that's going to make the text chunks searchable. Next, you dump all those vectors, all those vectorized text chunks from all those images into a vector database. This is an abstract two-dimensional representation of a quote-unquote vector database. A vector is just a point in space. Now, in reality, these transformations typically transform a snippet of text into a vector that's hundreds of dimensions. But for simplicity's sake, imagine that each one is only 2 dimensions. Then it would look something like this abstractly. So this is the vector representation of all of our text snippets. When you query for something like eat both capsules, that query gets transformed using the same embedding model we use to transform the snippets. Then once that query is transformed into the same kind of vector, it can be compared to the other points in the database, and you can recover the image, the snippet it most closely aligns with, by calculating the actual distance between the vectorized form of that query and all those vectorized snippets. If you want to dig deeper into each component of that pipeline, go to the repository and open the Colab notebook that you find at the top of the README. I have it open here. This notebook walkthrough explains each of those steps in that pipeline in much more detail and includes code examples for each step of the process. If you'd like to see me walk through this notebook and discuss that code in detail, please leave me some comments below, and if enough people want to see that video, I'll put it together. That's about it. If you want to download and run this app on your home machine and dig into the details, pull the repo linked to in the description. Have a great day.